What's up, guys? Welcome to our today's class. I'm teacher Bruno at 254. Today we are going to learn about formula and variation. Remember, this one is a mathematics chapter in Form 3 syllabus, or let's say grade 3 at secondary level. Kindly remember to like, share, and subscribe to the video for more updates on more classes. My WhatsApp and email number on the screen. Let's go direct to formula and variation. By the way, what is formula and variation and what do we need to know under this unit? What type of problems do we expect to face on this unit? How are questions in this unit framed? But before then, we need to understand variation problems involve fairly simple relationship or basically formulas, and that can involve one variable being equated to one term, and for that case that term can either be linear, for instance x, quadratic, more than one variable as shown on the screen, or either square root as shown. Symbol, yeah, there is always just that one term in any given variation, and that term is denoted by k and is called constant of the variation. We shall see in the following sections what that constant stands for and how we calculate that constant. Symbol. And how does that variable relate to another one in a given formula? How does a variable relate to another in a given formula? And to understand this, we need to look at the following summary of variables relationship between one and another one in a given formula. And the first case is a direct relationship. For instance, we can have f varying directly as x, or f varies xx, and that is denoted by f is equals to kx, where k here is the constant. By replacing equal sign with the symbol shown there, we get f is direct proportion to x. And what does that mean? As f increases, x also increases. That is, they vary directly. The second case is joint relationship. That is, f varying jointly as x and y. In this case, we have two variables, x and y, varying jointly as f. What does that mean? As the product of x and y increases, the value of f increases. That's simple. K is the constant. The next one is f varies as x and y. That is, f varies as the summation of x and y. That means as the summation of x and y increases, so does the value of f. Simple. The other one is inverse relationship, inverse variation. In this case, f varies inversely as x. What does that mean? First, let's look at this formula. F equals to k over x. Simple. K is the constant and x is the other variable. Therefore, as the value of x increases, the value of f decreases. That is, f is inversely proportional to x. As one increases, the other one decreases. K remains constant all through. Let's see this one with examples to understand the topic better. But how do we interpret problems? How do we interpret variation problems? This should not give you an headache. Once you get the hang of it, it will all be simple. Generally, These problems fall into two categories, broad categories, and these categories include: the first one is where you are asked to find the value of k, or the constant, and the other one is where you are given the value of k and either one of the variables and asked to calculate the other value. What happens in all those cases? You first find the value of k. You first look at the value of k. Kindly note that one. The value of k is critical. First look for it. Next, we need to start with an example. And that example is, if y varies directly as the square of x and y is given as 8 while x is given as 2, kindly find the value of x. Value of y when x equals to 1. As you can see from this problem, we are first given the values of y and x and given the relationship between y and x squared. So what have we said earlier? We said that we need to calculate the value of k. We first need to get the value of the constant, but before then we need to interpret this problem to a formula. And how do we do that? Since this is a direct variation, we know that y equals to constant k x squared, and that symbol y varies directly as x squared. Now we are given the data points x and y as 8 and 2. So using these two, we are able to find the value of k. By plugging in these two data points, we can get the value of k. This symbol 8, which is the value of y, equals to k, which is the constant, and 2, which is the other value of x squared. After squaring the value of 2, we get 4. So 4 times k is 4k, which is equal to 8. Then divide on both sides by 4, we have 2. Now that we have the value of k, we can rewrite the formula as follows: y equals to 2x squared. That's our formula. With this, we can now answer the question. We are told to find the value of y, while we have the value of x as 1. Replacing x in the previous formula shown here, we have y equals to 2 times the value of x is now 1, and now we get 2 times 1 squared, and the answer is y equals to 2 times 1, and that is y equals to 2. So now we have the value of y. Congratulations. Now we can move to the next section, to the next example, and see what it entails. Example 2 is a joint variation. Now if y varies jointly as x and z, and y is given as 5 while x is 3 and z is 4, find the value of y given x is 2 and z is 3. Now we need to come up with the formula, and the formula is y equals to kxz. Why? Because we said earlier that joint variation simply means that we get the product of the variables. So in this case, k always remains as a constant, while x and z are the two variables that jointly vary as y. So k x z. Now that we have the formula, you can go to the next step. Now, by plugging in the data points given, which is y equals to 5, x equals to 3, and z equals to 4, we can get the value of k. And how do we do that? We just replace directly y by 5, x is replaced with 3, and z is replaced with 4. We get 5 equals to k times 3 times 4. Multiplying 3 by 4 we get 12, where 12 times k is 12k is equal to 5. Dividing on both sides by 12 to get the value of k, we have k is 5 over 12. Nice. Next step. Now that we have the value of k, we need to replace that value in our previous equation shown here. Now we have y equals to the value of k, which is 5 over 12 x times z. Now that our question was find the value of y when x is 2 and z is 3. Now that we have the value of k, we can replace x with 2 and z with 3, where we get y equals to 5 over 12 times 2 times 3. Now that y equals to the product of the previous part, where it is 5 over 12 times 2 times 3, we get 5 over 2. Therefore, we have the answer, the value of y as 5 over 2, which is an improper fraction, which can be further simplified. I leave that one as an assignment to you to simplify it to the simplest form. Let's go to the next example. Our example is on inverse variation. Now that given y varies inversely as the square of the difference of w and x, and that y is equal to 6, while w equals to 2 and x is 1. Find the equation for y. That's simple. Why can't we just write why can't we convert the problem to a formula? I said earlier that when a variable varies inversely as another one, we have a fraction being formed, and the numerator is always the constant k. So step 1 is creating the equation. And how do we create that equation? Based on this information, we understand that we have a constant as the numerator and a rational expression as the denominator. So that simply means that we start with the reread the question. Given that y varies inversely as the square of the difference of w and x. Now, there's something you should have noted there. We have a difference of w and x. Why can't we start from there? So you write w minus x. Next, we are trying to create the formula. The difference of the two. Now we have the y varies inversely as the square of the difference of w and x. Now the square of that difference. So the next step is adding a square to the difference of w and x. And that becomes w minus x into bracket squared. Then after that, since we are told it's a inverse variation, we just sum the equation into y equals to k being the numerator, which is the constant, over w minus x squared. And with that, we have the equation. But wait, we need to calculate the value of k, which is the constant. How do we do that? We just need to replace the previous values of y, w, and x into the equation. And that becomes 6 equals to k, 3 minus 1 squared. First, subtract 1 from 3, and we get 2. You need to square 2 squared, which is 4. Do away with the numerator, with the denominator, which is by multiply all through by 4, where we get k is equals to 24. Last step, replace the value of k to the previous equation shown here. We get y equals to 24 over w minus x into bracket squared. That was that simple. That was easy. I guess you also found it to be easy and interesting. Now help with the 3 examples you have handled. At least you can do something. Let's see what we need to do next. it is example 4. And with example 4, we are given quantity z varying directly as the square of x and inversely as the square root of y. If x increases by 20% and y decreases by 36%, find the percentage change in z. Guys, look here. We have a combination of two types of variation, direct variation and inverse variation. This is a very interesting question. We need to exercise what we have learned previously. And after that, we need to add more knowledge on how to calculate percentage change in a formula. So this is the solution. Step 1, you need to write the equation. How do we write the equation? Z, first start here. Z varies directly as the square of x. Write that one first. Z equals to k, which is a constant, x squared. Next step, and inversely as the square root of y. Add that part. So we need to divide what we have written or have already written on the right side with the square root of y. So we get the equation z equals to kx squared over root y. Step 2 is replacing the percentage change in values in this previous equation or in the previous answer. So z equals to the value of change in x, which is 20%. When we have a 20% change, that is increasing by 20%, that means the value was already at 100% and we increased by 20%. Now we are getting 120%. How do we write that one? It is 120 divided by 100, that is 120 over 100, that is 120%. So when you divide 120 divided by 100, you get 1.2. So we multiply the value of x by 1.2. Remember, it's the value of x which is changing, so we are writing 1.2 times the value of x all squared. The other value that had a change is the value of y that decreased by 36%. When a decrease in a variable happens, we subtract that value from 100%. So we have 100 minus 36 and we get 64. So 64% is 64 over 100, where we have 0.64 as the value. Now we multiply that value by y. And since the y was under square root, we have to cover both 0.64 times y under the square root. And what we get as answer? We need to open the brackets. And on opening the bracket, we have 1.2 squared, which is 1.44, and 0.64 after the square root, we have 0.85. Now, the next step is dividing the answer by 0.85 to get 1.8 k squared divided by root y. Therefore, we have the answer as 80% increase. Can someone tell me why we have 80% increase and not an 80% decrease? Okay, thanks. It's simple. We have 1.8. 1.8 means it's 1.8 multiplied by 100. That is 180. And since it is above 100%, we take that one as an increase. Therefore, 100 minus 180, we get a difference of 80%, which is the percentage increase. Now, guys, that we have covered what I prepared for you today, I expect you to go through the two questions and try to evaluate your understanding on the topic. Answers will be posted below as a comment, so kindly keep checking on after some time to reevaluate your your understanding of the unit. Thank you guys. Kindly remember to like, share and subscribe. Kindly. That will be a way of helping me grow this channel. Kindly leave your comment below. Comment on the topic that you'd like me to handle in future. Thank you guys. I love you all. It's me, Bruno254. All the best and success in your studies. Thank you.